Roger, go for launch.
T-minus 3, 2, 1.
Atlas engine ignition.
Liftoff of the United Launch Alliance Delta IV Heavy rocket.
This is Delta Mission Control at T-minus 4 minutes, 21 seconds and counting. In just a few moments, the launch count will enter a planned 15-minute hold. This hold allows launch conductor Ed Kidda and the team time to conduct final systems checks and resolve issues prior to entering the terminal count. Today's 40-minute launch window opens at 8:07 p.m. Eastern Time. Good evening and welcome to Cape Canaveral Air Force Station. I'm Trevor Kilpatrick and I'll be your commentator for tonight's launch. Later in the broadcast, Captain Doug Downs from the Air Force's Space and Missile Systems Center will join me. Captain Downs works directly with the WGS satellite maker Boeing's engineers as the Wideband Global Satcom Channelizer Project Manager. Today's launch is the 7th satellite in the Wideband Global Satcom system. Built by Boeing Space and Intelligence Systems, WGS is an important element of the high-capacity satellite communications system, providing enhanced communications capabilities to U.S. and allied warfighters for the next decade and beyond. Each WGS satellite provides more wideband communications capacity than the entire defense satellite communications system, the constellation that WGS is replacing. United Launch Alliance is using the Delta IV Medium Plus 5-4 configuration to launch WGS-7. This is the 30th Delta IV Evolved Expendable Launch Vehicle mission since the inaugural flight in 2002, and the 5th flight of the Medium Plus 5-4 configuration. The Delta IV rocket is produced in Decatur, Alabama, and is comprised of a common booster core powered by the Aerojet Rocketdyne RS-68A engine, 4 Alliant Tech Systems solid rocket motors, and a Delta cryogenic second stage powered by the Aerojet Rocketdyne RL-10B2 engine. WGS-7 is protected during ascent by a 5-meter diameter payload fairing. On June 23rd, WGS-7 was encapsulated inside its fairing, and on July 8th, the encapsulated payload fairing was transported to the Mobile Service Tower, or MST, and mated to the Delta IV. The MST is located at Space Launch Complex 37. At about 11 a.m. today, the MST was raised 8 inches and rolled back, revealing the Delta IV launch vehicle. The 33-story MST weighs about 10 million pounds and is rolled to its launch position 345 feet north of the Delta IV launch vehicle. The Delta IV stands 217 feet tall, or nearly 22 stories, and weighs about 900,000 pounds when fully fueled. The Delta IV produces more than 1.5 million pounds of thrust at liftoff. Approximately 4 minutes later, at stage separation, it weighs just 20% of what it did at liftoff.
The following profile details the important events of this mission using approximate times.
We have ignition of the RS-68 main engine. 2, 1. And we have liftoff of the Delta IV launch vehicle carrying
the Delta RS-68A main engine and 4 strap-on solid rocket motors ignite to lift the vehicle away from the pad. Shortly after liftoff, Delta begins its initial pitch and yaw maneuvers to attain the proper ascent profile and minimize aerodynamic loads. Delta IV reaches Mach 1, the speed of sound, at 33 seconds. At 45 seconds, the vehicle reaches maximum dynamic pressure. The strap-on solid rocket motors, or SRMs, burn out approximately 92 seconds into flight. At 1 minute 40 seconds, the first 2 SRMs are jettisoned. 2 seconds later, the remaining 2 solid rocket motors are jettisoned. The payload fairing is jettisoned at 3 minutes 4 seconds. Approaching booster engine cutoff, the Delta IV is burning propellant at the rate of approximately 994 pounds per second, flying at more than 118 miles in altitude and 216 miles downrange. Booster engine cutoff occurs just under 4 minutes into the flight. 6 seconds after booster engine cutoff, the first stage is jettisoned. Main engine ignition takes place at 4 minutes 15 seconds into the flight. The second stage and WGS satellite are now in the first burn, the longer of the two second stage engine burns. Following the second stage engine cutoff at approximately 20 minutes, the mission enters a coast phase. Just over 29 minutes into flight, the second stage main engine is reignited for the second and final burn. Following the final second stage main engine cutoff, the second stage and payload enter a coast period in preparation for spacecraft separation. At 41 minutes 59 seconds into the mission, the second stage releases the wideband global SATCOM satellite for the United States Air Force.
Master script running.
Roger.
Tonight's launch is dedicated in memory of Robert E. Morgan, Jr. Bob was a man of integrity, a principle he brought to work every day of his long career. Bob spent much of his career working in launch operations, processing Delta II vehicles for launch. He transferred to production operations in Decatur, Alabama, where he led the Delta IV engine section team before his assignment in the Transportation Ground Support Equipment Group. Bob especially enjoyed launch day and would often share his many experiences with his teammates. He left a lasting impression on every person that he touched during his career and will forever be remembered as a good man and a great coworker.
L-8 minutes.
This is Delta Mission Control at T-minus 4 minutes and holding. We remain in the planned 15-minute hold as launch preps continue. Launch conductor Ed Kidda will pull the team in a few moments for the final go to resume the Delta IV launch countdown. 31 engineers and managers will be pulled for system status and readiness to proceed. This is the final status check before launch for all Delta vehicle systems, ground systems, the spacecraft, and the U.S. Air Force Eastern Range. The vehicle system readiness poll includes electrical systems, hydraulics, pneumatics, propulsion systems, flight control, and propellants. Final processing steps just prior to launch include completing propellant topping of both vehicle stages, securing propellant tanks, and pressurizing tanks to flight pressures. Let's listen as Ed Kidda performs the final polling of the launch team.
LH2 conditioning is complete. Roger. All steps complete prior to the status check.
L-7 minutes.
Status check to proceed with terminal count. MEQ.
Go.
MEA.
Go.
HYE.
Go.
LOX 1.
Go.
LOX 2.
Go.
VP.
Go.
P&E.
Go.
BP.
Go.
ATC 1.
Go.
PEA.
Go.
Fuel 1.
Go.
Fuel 2.
Go.
TM 1.
Go.
ATC 3.
Go.
TM 2.
Go.
FMA.
Go.
VE.
Go.
EEA.
Go.
GE.
Go.
SYS.
Go.
DSE.
Go.
Timer.
Go.
ECS.
Go.
QE.
Go.
USO.
Go.
OSM.
Go.
VSE.
VSE is go.
ALC.
Go.
AC.
AC is go.
RC.
Clear to proceed.
LD.
Launch vehicles ready to launch.
MD.
You have permission to launch.
Proceeding with the count.
L-6 minutes.
MEQ establish swing arm lock pins pull.
Active.
SYS establish record on change list.
Polling is complete, and the launch team has given the go for launch. The countdown will resume approximately 2 minutes from now. At T-minus 4 minutes and counting, the team will enter the terminal count and will begin securing the second stage liquid oxygen tank. At T-minus 3 minutes 32 seconds, CBC liquid hydrogen and liquid oxygen tank securing is started, which includes closing the propellant fill and drain valves. Also at T-minus 3 minutes 32 seconds, vehicle transfer from ground facility power to its own internal battery power will be complete. At T-minus 3 minutes, the vehicle ordnance system will be armed, and the CBC liquid oxygen and liquid hydrogen propellant tanks are verified to be at flight pressure and flight level. At 2 minutes prior to liftoff, the team will verify that the hydraulic system is pressurized, as well as confirm CBC, DCSS, and FTS battery voltages. At T-minus 1 minute 20 seconds, the team will begin securing the second stage liquid hydrogen tank. At T-minus 60 seconds, the Eastern Range readiness is verified. At T-minus 50 seconds, the DCSS liquid hydrogen tank is secured at flight level. A final launch vehicle and spacecraft status check is conducted at T-minus 25 seconds. At T-minus 15 seconds, the ROFIs, or sparklers, are ignited to burn off excess hydrogen at the base of the vehicle. Liftoff will occur at T-minus 0. After liftoff, you'll hear the voice of Steve Agid providing launch vehicle ascent data. This is Delta Mission Control at T-minus 4 minutes and holding. We anticipate picking up the launch count in just a few moments.
T-minus 4 minutes and counting.
Upper stage lock securing started. CBC propellant securing started. Vehicle transferring internal.
3 minutes 50.
The countdown clock has resumed, and we are proceeding towards an 8:07 p.m. Eastern liftoff.
T-minus 3 minutes 32 seconds.
Vehicle transfer internal. Complete.
3:30.
T-minus 1 minute and counting.
Fox go. Rock, report range status.
This is the Rock, range green.
50 seconds. 45.
Launch enabled. GE main power off.
Main power off. Upper stage LH2 secure at flight level.
T-minus 30 seconds.
T-minus 30.
Status check.
Go Delta.
Go WGS.
25.
Green board.
Flight lock in.
23.
SRM TVC blowdown.
15.
Rofi ignition.
10.
T-minus 10, 9, 8, 7, 6, 5, 4, 3. We have ignition. 2, 1, 0, and liftoff of the United Launch Alliance Delta IV rocket carrying the 7th WGS satellite for the United States Air Force. The wideband global SATCOM satellite provides significantly increased capacity for our nation's leaders, warfighters, and international partners.
Maximum SRM chamber pressure now. Coming up 30 seconds. 34 seconds, Mach 1, vehicle now going transonic. Passing 40 seconds, altitude 3.7 nautical miles. 45 seconds, maximum dynamic pressure, max Q on the vehicle. 50 seconds in. Altitude 6.38 nautical miles, velocity 2,532 feet per second, downrange distance 4.43 nautical miles. 1 minute into the flight.
You are hearing the voice of Steve Agid providing launch vehicle ascent data.
Miles, velocity 3,646 feet per second, downrange distance 7.44 nautical miles. Standing by for a solid rocket motor burnout, about 10 seconds from now. And we have burnout, standing by for SEP. And we have separation. 4 solid rocket motors have separated. 1 minute, 50 seconds in. Delta vehicle now weighs half of what it weighed at launch, expelling propellant at the rate of 1,945 pounds per second. 2 minutes into the flight. Altitude now passing 35.5 nautical miles. Velocity 6,443 feet per second. Downrange distance 34 nautical miles. 2 minutes, 14 seconds in. past Mach 5. Hydrogen supply valve on the second stage are open, allowing fuel for our second stage flight. Passing 2 minutes 31 seconds. 2 minutes 40 seconds in. Altitude 54.7 nautical miles, velocity 8,773 feet per second, downrange distance 67 nautical miles. Fairing separation should be about 15 seconds from now. Standing by. And fairing SEP. Good fairing SEP, 3 minutes 14 seconds in. 75.5 nautical miles in altitude, 12,000 feet per second, downrange distance 116.8 nautical miles. 3 minutes 28 seconds in. We'll be going to the partial thrust mode about 15 seconds from now. 57% thrust level, standing by. And we've been commanded to partial thrust. Standing by for main engine cutoff. Main engine cutoff. Standing by for stage SEP. And we have stage separation. NEDS is deploying. Standing by for the igniter spark. Igniter spark, standing by for ignition. And we have ignition. Ignition on the second stage. Second stage chamber pressure is coming up. Good chamber pressure on the second stage. Good stable burn. Recovering from the initial ignition transients. 4 minutes, 41 seconds in. Altitude now passing 144 nautical miles.
This is Delta Mission Control at AL plus 4 minutes 58 seconds. We've just heard Steve Agid report the successful execution of the early events of tonight's flight, and all systems continue to operate nominally. The Delta IV and WGS satellite are traveling southeasterly over the Atlantic Ocean, away from the Florida coast. The mission is now in the first of 2 planned RL-10 engine burns. This burn will last approximately 16 minutes. I'm joined now by Captain Doug Downs of the Air Force's Military Satellite Communications System Directorate. Captain, thanks for joining me.
Thanks, Trevor. It's an honor to be here.
So what does the WGS system provide to the warfighter?
Well, Trevor, the WGS system, which was first launched in 2007, provides the warfighter with worldwide, anytime communications. A single WGS satellite has more communications capability than the entire Discus constellation. On top of that, it also provides the ability for crossbanding, which means you can connect the X-band and Ka band for users that might be on those different bands at any time. This provides the unique ability to support the warfighter whether they're at tactical headquarters or on the move. WGS currently collects and routes real-time data through thousands of fielded terminals worldwide, supporting tactical communications. WGS satellites also support the Global Broadcast System, also known as GBS. You can think of this as being like DirecTV. It's always there, always broadcasting. You just have to tune in. Warfighters can do that to get some situational awareness. In addition to providing the essential communications for the command and control of deployed forces, WGS also provides the warfighter with a 24/7 means of communication, allowing for coordination of efforts or calling for support if required.
Okay, so for users that may not have a real good understanding of satellite communications, can you explain a little bit more about how that works?
I'd be happy to, Trevor. So it starts off with some information that needs to get from one point to another. For example, let's say a combatant commander in Afghanistan needs to get some support from Allied forces on an aircraft carrier in the Indian Ocean. So in the past, the way you had to do this, way back, you started with signal fires, smoke, flags, things like that. And you moved on to wires and eventually terrestrial radio. But all of these methods have some drawback. Either speed, it takes a long time to get that message over, or you have line of sight issues. If you don't have a direct link, a mountain's in the way, won't be able to make that communication. So to solve this problem, you can put a satellite above the Earth at about 22,200 miles. So at this distance, you see about a third of the Earth's surface. From that position, your satellite, in this case WGS, can send and receive communications almost instantaneously, 24/7. And in our case, the battalion commander would be able to use an antenna within that field of view of the satellite, that 1/3 of the Earth's surface, send the communication to the satellite, they'll collect it, route it, send it back down to the Allied forces on the aircraft carrier. It doesn't matter how far apart they are or what is in the way, that communication will get through.
Wow, fantastic. That's some impressive stuff. Can you tell us a little bit about the WGS-7 satellite itself?
Well, the WGS-7 satellite is rather impressive itself. So on orbit, when it's in its final position, it'll weigh around 7,600 pounds. So to put that in perspective, you're talking about the weight of a 3/4 ton pickup truck. And then once the solar arrays are fully deployed, so from tip to tip of those arrays, you're looking at 135 feet, which is even more than the aircraft that you might have flown into the Cape with, which is probably a Boeing 737 or something similar. WGS-7 will orbit the Earth in a geostationary orbit, which means the amount of time it takes for the satellite to orbit the Earth is the same amount of time it takes the Earth to revolve once about its axis, so about 24 hours. This unique orbit allows the satellite to stay directly over a given point on the equator, so you don't have to try to be adjusting to maintain communication. To make this happen, you have to have the satellite at about 22,200 miles above the Earth's surface and be traveling around 6,800 miles per hour, which is smoking. You're moving fast at that point. And over the 14-year design life of a WGS, you're going to travel 900 million miles. Wow. With WGS seeing nearly a third of the Earth's surface and providing critical communications ability, it's an absolutely necessary asset.
Excellent. Well, Captain Downs, it sounds like you have a fascinating job. If you don't mind, can you stay with me for a little bit longer? I might have some more questions for you.
I certainly will.
This is Delta Mission Control at T plus 12 minutes, 24 seconds. We're approaching the end of the first of two planned RL-10 second stage engine burns. The Delta IV and WGS satellite are flying over the Atlantic Ocean off the west coast of Africa. Our next event, the first main engine cutoff, or MECO 1, is scheduled to take place just about 7 minutes from now. While we wait for the next mission event, let's take a look at a video highlighting the important capabilities of the WGS system.
Bulldog, Benji, do you copy?
I copy, Mark.
15-second AB takeoff. Please contact Center 150-26-27,000.
5 Sierra 4 kilo.
1 very roger out. Roger, 22, say your fuel. 3 miles, 20 seconds.
And liftoff of the Atlas V rocket carrying the WGS SB-1 spacecraft, WGS-2,
WGS-3,
WGS-4,
WGS-5, WGS-6 satellite for the United States Air Force.
WGS today provides critical and vital wideband communications capability to the warfighter and international partners.
It's a global reach system so that no matter where you are, what time of day, WGS can reach you.
And with the wideband communications, we're able to direct forces all over the world. This can mean the difference between life and death, between mission success and failure.
We're talking about the sailors, soldiers, marine, and airmen in the Middle East or anywhere that is needed.
Being able to communicate over the same system allows joint, seamless operations anywhere on the globe, whether it be for humanitarian efforts or in the presence of a hostile environment.
One can imagine a very adverse situation where our servicemen need immediate communications, it's always there for them. It's like a beacon in the sky.
The Air Force has partnered with allied nations to provide a cost sharing in the WGS system. In turn, these nations have access to the WGS fleet.
They take advantage of the on-orbit infrastructure and are able to get preemptible bandwidth across the entire constellation.
We benefit from it, they benefit from it. This helps build our coalition.
What WGS represents to Australia is our ability to operate with our allies across the globe, and I can assure you that while the world is uncertain, the Australia-US alliance is an absolute certainty, and WGS represents that.
Vehicle over vehicle, block over block, the satellite has been able to evolve and provide significantly increasing capability while driving down the recurring cost of each vehicle.
WGS is unique in that it features an advanced phased array antenna. This antenna is capable of reshaping the coverage pattern at any point.
And put communication where it needs to be.
We also have cross-banding capabilities, so we can go up in one band and down in another.
What it does is receive the X-band capability, and then through the satellite it converted to Ka band.
So no longer are soldiers, warfighters, or humanitarian aid personnel limited by the type of ground terminals they have.
In our Block 2 satellites, which is 4 through 6, we introduced RF bypass,
which allows UAVs capability to broadcast high-definition video over our Ka band antennas.
Making sure WGS can operate without being subject to malicious activity is one of the key concerns of the WGS program.
So in cases of jamming, our antennas are reconfigurable to eliminate the effects of any unintended interference from a jammer.
This removes the adversary from the line of sight and restores normal communications to the system.
It has the ability to continue to evolve to meet the needs of the warfighter into the future.
One of WGS's core missions is to support humanitarian efforts.
Recently, WGS was critical in making connections between X-band and Ka band for tsunami relief in Japan.
The Japanese emergency equipment operate on the Ka band, and WGS was able to provide that Ka capability.
There's an incredible amount of pride working on the WGS system, knowing it saves lives and keeps people out of harm's way.
Whether it's important military operations or just allowing someone who's deployed to speak to their friends and family back home. It's a good feeling, and I think we're doing a good mission here.
Continues to look good. Good engine control on the second stage. Altitude now 149.2 nautical miles. Velocity increasing to 26,097 feet per second. Downrange distance 2,538 nautical miles.
This is Delta Mission Control at T plus 17 minutes 59 seconds and counting. The Delta IV rocket carrying the WGS-7 satellite lifted off from Space Launch Complex 37 at 8:07 p.m. Eastern Daylight Time. We're about 2 minutes away from completion of the first of 2 planned RL-10 engine burns. Let's join Steve Agid for mission progress.
Seconds. Altitude 137.2 nautical miles. Velocity increasing to 26,908 feet per second. Downrange distance 2,683 nautical miles. 18 minutes, 30 seconds in. 1 minute, 25 seconds remaining in the burn. Chamber pressure continues to look good, and engine control continues to look good. $18 minutes, 45 seconds in, 1 minute, 10 seconds remaining until cutoff of the second stage. Coming up on 19 minutes. Mark, 19 minutes into the flight, about 55 seconds remaining in the burn. Chamber pressures continues to hold. Good engine control. Okay, 19 minutes, 30 seconds in. We'll be standing by for the second stage engine cutoff about 20 seconds from now. "19 minutes, 42 seconds in. Standing by for shutdown. And we have cutoff. Second stage engine has shut down. Now 20 minutes, 15 seconds into the flight. The second burn of the second stage take place approximately 9 minutes and 20 seconds from now. About 19 minutes, 57 seconds correction.
This is Delta Mission Control at T plus 20 minutes, 39 seconds. We just heard Steve Agid report successful cutoff of the RL-10 second stage engine. The mission is now in a coast phase, which will last about 9.5 minutes. Let's listen in as Steve Agid continues to report mission progress.
Standing by. And we have igniter spark. And we have ignition. Ignition on the second stage chamber pressure rising. Good chamber pressure in the second stage. This burn is to last 3 minutes, 18 seconds. Altitude now increasing.
This is Delta Mission Control at T plus 30 minutes and 2 seconds. Steve Agid has just confirmed restart of the RL-10 engine. This second burn will last just over 3 minutes. Our next event, MECO 2, completes the engine burns for this mission. Here again is Steve Agid.
Control. Now 30 minutes and 30 seconds mark into the flight, about 2 minutes and 20 seconds or so remaining on the burn. Altitude now passing 310 nautical miles, velocity 29,614 feet per second, downrange distance 5,885 nautical miles. 30 minutes, 50 seconds in. About 2 minutes remaining in the burn. Good chamber pressure and good engine control, passing 31 minutes now. About 1 minute and 40 seconds remaining on the burn. 31 minutes, 15 seconds into the flight. Altitude now 342.58 nautical miles, velocity 30,481 feet per second, downrange distance 6,058 nautical miles. 31 minutes, 30 seconds in. Good engine control, chamber pressure holding. About 1 minute and 15 seconds now remaining in the burn. 31 minutes, 40 seconds in. Altitude continues to increase, now at 364.6 nautical miles, velocity 31,061 feet per second, downrange distance 6,170 nautical miles. Coming up on the 32-minute mark. 32 minutes into the flight. Less than 1 minute remaining on the burn. Chamber pressure continues to look good. Engine control continues to look good. Coming up on 32 minutes, 20 seconds. Less than half a minute now remaining on the burn. After this burn is complete, we should have a little over 9 minutes until payload separation. Standing by for second stage engine cutoff. And we have shutdown. Engine has cut off. Now 33 minutes, 3 seconds into the flight.
We just heard confirmation of the successful cutoff of the RL-10 engine. The mission is now in a 9-minute coast phase flying above eastern Africa. Separation will occur over the Indian Ocean east of Madagascar.
We've received the second set of orbit numbers. They look very, very good. Now about 4 minutes, 40 seconds remaining until the expected time of the spacecraft separation. This is Delta Flight commentary at 38 minutes, 25 seconds in, 3 minutes, 32 seconds remain until spacecraft separation. This time, the altitude now has increased to 993 nautical miles, velocity 30,585 feet per second. That downrange distance, 7,802 nautical miles. About 3 minutes, 10 seconds until spacecraft separation. This is Delta Flight commentary, 39 minutes, 32 seconds in, about 2.5 minutes remain until spacecraft separation. Altitude now 1,119 nautical miles, velocity 30,112 feet per second. The downrange distance 7,999 nautical miles. Coming up on 2 minutes until spacecraft separation, 39 minutes, 53 seconds into the flight, and 2 minutes until spacecraft deploy. Now 40 minutes, 33 seconds into the flight, less than a minute and a half until the expected time of spacecraft separation. Now 41 minutes into the flight, less than 1 minute until spacecraft sep. This is Delta Flight Commentary at 41 minutes 25 seconds in. Standing by for spacecraft separation about 30 seconds from now. Standing by for SEP about 10 seconds from now. And we have two good brake wires and separation, spacecraft separation, WGS-7 now flying on its own.
Well, Captain, we have successful separation. Congratulations on the deployment of WGS-7.
Thanks, Trevor. This is another important milestone for our warfighters, our nation, and our allies. Go wideband!
I'd also like to thank Steve Agid for his participation. For more information about this mission, you can visit us at ulalaunch.com or follow us on Facebook or Twitter. We'll leave you with another look at liftoff of the Delta IV rocket carrying WGS-7. I'm Trevor Kilpatrick. On behalf of the entire launch team, thank you for joining us and have a great night.
15.
Roll for ignition.
T-minus 10, 9, 8, 7, 6, 5, 4, 3. We have ignition. 2, 1, 0, and liftoff of the United Launch Alliance Delta IV rocket carrying the 7th WGS satellite for the United States Air Force. The wideband global SATCOM satellite provides significantly increased capacity for our nation's leaders, warfighters, and international partners.